So this is the second set. Let us carry on with this. The mirror image of the above text about the x-axis. So let us check it out. See, the mirror image of this S will be something like this. I will be this. X will also be this. A will also be this. Now L will be something like this. Y will be something like this. H would be something like this. And P would become something like this. So you see, this would be the image. Let us check out which one holds. And if you observe properly, it is option A which holds. Check. Only option A holds. So I will say option A is the answer. Let us do this one. In an equivalent, this is a misprinting. It won't be equivalent. It can't be equivalent. It should be equilateral. In an equilateral triangle PQR, side PQ is divided into 4 parts. Let us do that. Let us suppose this is our equilateral triangle P, Q, and R. Equilateral triangle means all the sides are equal. So side PQ is divided into 4 parts. So this is divided into 4 parts. Side QR is divided it into 6 equal parts. All of these are equal parts. And this is divided into 8 equal parts. They have said that the length of each subdivided part in centimeter is an integer. So each of these subdivisions is integral. The values are integral. What is the minimum area possible of the triangle PQR? So immediately the first point that will come to my mind is the side PQ, and PQ is equal to PR is equal to QR. So side PQ must be such which should be the shortest but should also be perfectly divisible. No remainder, because any remainder means decimal values will come. Fractional values. So perfectly divisible by 4, 6, and 8. So how do I find that? Minimum side, which is perfectly divisible by 4, 6, and 8. Simply find the LCM of 4, 6, and 8. Now 4 and 8, the LCM is 8. 6 and 8, the LCM is 24. So I will say 24. So immediately I will say that each side must be equal to 24. Now why did I take the smallest side? Because if only it has the smallest side, will the area be the smallest? So minimum area means the minimum sides. So 24. Now we know that the area of an equilateral triangle, is always given by root 3 by 4 a square, where a is the side of the triangle. So here also let us do it. So area of this equilateral triangle PQR will be equal to root 3 by 4 multiplied by how much? Now 24 square. So 24 into 24. So 4 6s are 24. And 6 into 24 is 144. So the result is 144 root 3 centimeters square. Okay. So this is our answer. Hope that is clear. 4 persons P, Q, R, and S are to be seated in a row. R should be seated at the second position from the left end of the row. The number of distinct seating arrangements possible is how much? Let us check. See if these were the four rows, and let us suppose I say that P, Q, R and S can be seated anywhere, means I am now not following this instruction, the second instruction. P, Q, R, S can be seated anywhere. Then in how many ways could they have seated themselves? See, 4, 3, 2, 1. So that is equal to factorial 4 ways they could have seated themselves. Now, let us suppose I say that R is seated to the second of the left. It has been said R should not be, but I have deliberately taken that R is seated to the second of the left. So in how many ways can the three other people, P, Q and S, fill these three positions? See, 3, 2 ways and 1 way. So that is equal to factorial 3 ways. Right? So here what will I say? The number of distinct seating arrangements where R should not be seated at the second position would be factorial 4 minus factorial 3. All these cases which are present in factorial 4, subtract that. The balance would give me where R should not be seated. So that is 24 minus 6. That is equal to 18. So the answer would be 18. In the figure shown above, PQRS is a square. The shaded portion is formed by the intersection of sectors of circles with radius equal to the side of the square and centers at S and Q. It means, suppose if this is the square, then on one circle the center is this, the radius is this part, and this is drawn. So this is the first sector. Now suppose if this is the square, the second circle, the center is here, the radius is this. The radius is this, and this is the sector. Now, if I join them, you see the common part of them is this. I hope we have all understood that. Okay. If I join them, the common part is this. Okay. Now, they have asked you the probability that any point picked randomly within the square falls in the shaded area. So I will say now that the probability of what has been said by this, rather than writing it and pointing, this would be nothing but the total outcome being the area of square and the favorable outcome being the area of this portion. Yes or no? This is our challenge actually. Now how to find the respective areas? See, let us take the side of the square to be 1. If this is 1, all of them are 1. So I can say area of square is equal to 1 into 1, that is 1 square centimeter. But if this side is 1, then this sector is nothing but a quarter circle of radius 1. So what is the area? The area would be equal to pi r square, but a 1/4 before it because this is quarter of that. So 1/4 into pi into r is 1. So into 1 square. So that is equal to pi by 4. Now what will be the area of this one? The area of that one will also be a quarter circle into pi into 1 square, right? So this would also be pi by 4. So can't I say that area of this would be equal to area of sectors, the summation of that minus area of square? Yes or no? If from the summation of this I deduct the area of the square, only this one will be left. So I will say the area of this would be equal to area of sectors. That means pi by 4 plus pi by 4 minus area of square, that is equal to 1. Now what is pi by 4 plus pi by 4? It is nothing but pi by 2. So the answer is pi by 2 minus 1 area of this. So then what is the probability? This would be pi by 2 minus 1 divided by area of the square is 1 square centimeter. So the result is pi by 2 minus 1. This is our answer. Let's go to the next one. I hope this is conquered. See, these two operators are two operators on numbers p and q such that this operator indicates a minus and this operator indicates a multiplication. So what will this turn up to be? This will turn up to be simple 9 minus 6 into 7 minus 7 into 6 minus 5. So let us solve this. So the first part would be 42. 9 minus 42 will be equal to minus 33. There is a minus sign. And 7 into 1 is 7. So this is equal to minus 40. Right? Arun and Aparna are here. Arun and Aparna is here. Arun's families is here. And Arun's family is here. Which of the above sentences are grammatically correct? It's a very simple case. Just by reading it, we can say that you see only these two are grammatically correct. The rest of these two are wrong. So we will say 1 and 4 are grammatically correct, which is this option. Let's go to the next one. Some football players play cricket. So that can be expressed as, see, some football players play cricket. It could also have been expressed as this way and also this way, because some can indicate but include 100%. Now all cricketers play hockey. Where do I show that? Let me show that here. All cricket players play hockey. So that can be done by like this. And there is another one. That cricket players and hockey are the same way. So now we will have to, think together the most significant ones. And the most significant ones would be this one and this one. So let us, take them together and let us see what can be the result. You see, this is football and this is cricket. Now, hockey, all cricket players are hockey, but nothing is known about the football players. So it might be possible that all the football players are also hockey players. Or it might also be possible that only some of the football players might be hockey players. It can never be possible that no football players are hockey players, because at least this part of football players will be into cricket, and cricket, all of them are hockey players. So some footballers will definitely be a part of hockey. So this is hockey. Now let us check the statements. All hockey players play football. Is that correct? Not at all. So I will say this is absolutely wrong. No football player plays hockey. Well, this can never be correct. As I said, at least this part of football players is bound to play hockey. So this is also wrong. All football players play hockey. Yes, very much possible. But so also is some football players play hockey, because that also is possible, right? So all football players play hockey is not always the truth. So I can't say that it is true. Now comes some football players play hockey. Now can't we say that because some includes total also, all is included, 100% is included within some, plus the normal meaning of some is there. So won't I say that this justifies that some football players will always be playing hockey, whether it be this minimum one, whether it be this minimum one plus this one, or whether it be apart from this plus this part. So I will say some football players play hockey is the right option. Correct? Let's go on to the next. Two identical cube-shaped dice, each with faces numbered 1 to 6, are rolled simultaneously. The probability that an even number is rolled out on each dice means on both the dices, even numbers will come up. So what is the probability of that? Now we know that probability of an even number is rolled out on each dice. So I'm not writing that. Will be equal to favorable outcome divided by total outcome. So what will be the, I say two dice are thrown simultaneously. So what will be the total outcome of them? There are 6 ways in which the first die can show us points, and so is here. So the total outcome would be 6 into 6, that is 36 ways. Now what is the favorable outcome? Now if we read a die, we will find that out of the 6 numbers that it provides, only 3 numbers are even. 2, 4 and 6. So if both of the die bring out even numbers, so the first die can do it in 3 ways and the second can do it in 3 ways. So the total outcome would be equal to 3 into 3, that is 9. Okay, so 9 ways. So I will say that the probability is 9 divided by 36. That is equal to 1 by 4. Let's go to the next one. On a planar field, you traveled 3 units east from a point O. So let us travel. You travel, see, we know that this is it. And this is north, this is east. So this is south, this is west. So from a point O, we travel 3 meters east. units east from a point. We travel 3 units east. Next, we traveled south. So south is this side. So we traveled south, and as you can see, we have traveled 4 kilometers south to arrive at a point P. So this is point P. Then you traveled from P in the northeast direction. What is the northeast? Northeast direction is this direction. So then from P I traveled in the northeast direction such that you arrive at a point that is 6 units east of point O. So 6 units east of point O will be somewhere here because this is 3. Then this will also be 3. So this would be the journey part, traveled from P in the northeast direction. Next, you travel in the northwest direction. So what is the northwest? Northwest direction is this direction. So that you arrive at a point Q that is 8 units north of point P. So 8 units north of point P is somewhere here. So I have traveled northwest and I have reached this point. Let us not forget if this point is 3. Let us not forget if from O to here this is 6, then this must also be 3. And let us not forget that from P to Q, if it is 8, then this must be 4. And they have asked you the distance of OQ. So the distance of point Q to point O in the same units is root 3 plus root 4. That is equal to, everybody knows this is root 5. So that is equal to 5. So 5 units is our answer. I presume that is clear. The author said musicians rehearse before their concerts. Actors rehearse their roles before the opening of a new play. On the other hand, I find it strange that many public speakers think that they can just walk onto the stage and start speaking. In my opinion, it is no less important for public speakers to rehearse their talks. Based on the above passage, which one of the following is true? Let's read it. The author is of the opinion that rehearsing is important for musicians, actors, and public speakers. I will immediately say that this is absolutely correct because the author throughout this passage is trying to say that thing only. And because which one of the following is true? So I have already arrived at it. So if it were an exam, I wouldn't have gone on to do anything about B, C, and D. They would, I would have automatically skipped them. I've got my answer. But this is not an exam. So let us just go through them. The author is of the opinion that rehearsing is more important only for musicians than public speakers. Nowhere has the author spoken of such a thing. They have never compared musicians and actors. You see, they've given equal importance. So this is absolutely false. The author is of the opinion that rehearsal is more important for actors than musicians. Once again, the author has nowhere compared actors and musicians. That's wrong. The author is of the opinion that rehearsing is less important for public speakers than for musicians and actors. Well, it has been said, in my opinion, it is no less important for public speakers to rehearse. No less important means it is very important. So this is absolutely the opposite thing, hence this is wrong. So our first statement stands as the true one. And so that's it. All the questions completed. Thank you very much.